What's up, guys? Another day, another video. Episode 46 today. We already took a look at this Pokemon yesterday. I was curious to see what was next and in the future. We got a Paras today. We're gonna take a look at the sound. Paras sound. That is our sound of the day. Make the Pokemon sound myself. And yeah. Let's take a look at a problem. Leetcode. Leetcode, check out our problem of the day. Let's take a look.
Might be another stack problem.
Might not be. Kind of looks like a stack problem here. Max sum of pair with equal sum of digits. You're given a zoom index array nodes consisting of positive integers. You can choose two indices i and j such that I does not equal j, and the sum of digits of the numbers I is equal to that of numbers j. Okay, so 0 and 2, both numbers have the sum of digits equal to 9. So 0 and 2, 3 and 6 is 9, 1 is 9, okay. And the sum is 18 plus 36 is 54. And we have 50 here, so we have, 1 and 4. 7 and 7, okay, it's 50. So we have 54 and 50 in the array, and then I guess we return the high sum of 54. Okay. Interesting problem, interesting problem. Array, hash table, sorting, heap, priority queue. I have an idea about maybe how we can implement this. But we're kind of going, I think this is more of like a complete brute force method. I definitely think there is a much better way to do this. I don't even know if this is going to be fast enough that it'll even accept, but I guess we can see. For length in nums. So we're doing the typical double for loop over and squared approach here. J plus 1. Sorry, in front of I plus 1, and we go to the length of nums. Here we want to check an if statement, so we want to check, well, if I does not equal j, so in this case we're looking at these numbers here. If I does not equal j, then we're looking at a number. So if I does not equal j, then we want to get we want to split this up so we can use, I think, this comprehension here. So let's do d1 is equal to d2 is equal to, how to do this on the top of your head in Python. Honestly, I'm not really 100% sure. I think it's, let's take a look. How to do list comprehension in Python. I always forget, man. For x for x, and fruits of a and x. Okay. So it's gonna make it a list. Just want to cast this as a digit and digit for, I guess, for digits in nums I think that'll work. And digit for digits in nums j. And obviously you want to check, well, if d1 is equal to d2, then they're the same. Sorry, if the sum d1, sum d2, if the sum of d1 is equal to the sum of d2, so if sum d1 is equal to sum d2, Dude, this is going to be such a bad approach, but Then we want to append res.append. We want to append some d1 plus some d2. Okay, then we want to do, well, let's an add is equal to the max of our res array, and then our default is equal to -1 if it doesn't appear, and we want to return ads. In digit for digits. In digits for digits in foods. I think this should work. Maybe we have to cast this as a string, I think, maybe. I don't know. Digit is not defined. I thought list comprehension we name. I'm so confused right now, dude. Name digit is not defined. Did you mean digits? I mean, oh, maybe it's talking about this one. I don't know, maybe. Okay. We want some, we check, well, some d1 is equal to some d2, res.append, some d1 plus some d2. Some d1. Oh, we're appending the wrong thing. We need to append nums I plus nums j. Okay. I don't think this is gonna pass. It's too slow. No. Way too slow. Again, I think this is too big for this to pass. We're doing too many calculations, so I think how can we make this faster? To be honest, I don't really know. How to get digit sum without converting it to string, then splitting, summing. Okay. I think this is what we got to change up here. I mean, it's kind of ridiculous, but well, none is greater than 0, digit sum plus equal. I just don't understand how this Kind of sad this doesn't at least pass. Okay, so in this better case, they use a hash map here and they process each number. For num and nums, digit sum is equal to sum. Oh, so what we did here, still using this comprehension here, they find the sum. If this sum of the digits is not in the dictionary, add it, and then they add it to the dictionary. Add the current number to the list for this sum of digits. Digit sum dot append now. This is an interesting way to approach the problem. We're gonna kind of redo this. I mean, we're gonna need this, so let's keep this here, right? So we want a loop for I in nums. Actually, let's just do for num in nums, right? We need to create a hash map. So let's do dictionary here. Okay, so we created our dictionary, so we want to check, well, when we're looping through the numbers, we want to check for each number, so I guess let's do our digit. For in digit, 4 digit in nums. Digit is equal to this, so for num in nums, we got our digit. Now I guess we do the sum around this, right? Yeah. Let's do sum digit is equal to this. Well, now if our sum digit is not inside our hash map, how do we do that? Then we add it. So then we do, well, minus the dictionary, sum digit. Yeah, is equal to this, right? And if it is, then we just increase it by 1. So we would do minus your dictionary, sum digit plus or equal to 1, right?
Oh no, we want to append it, so dot append num. Right, so here we're appending some, we're checking, well, some digit is already in it, right? So we're finding that variable, accessing that variable inside dictionary, and then we're appending our num, right? Okay, right, so then our I guess we can call this out res is equal to -1, right? We loop through our res, so we do, well, for we need to declare this outside of our for loop. So we do, well, for num list, well, let's do num list in MySQL dictionary dot items. Well, I guess we can just access our values here, right? Num list. What do we want to do? We're accessing each value, so we want to find the sum of our num list. So if the length is the length of the MySQL dictionary this is greater than 1, right? Because we only want to look for the numbers in list, right? Usually 2 vowels, right? Then we want to find the sum of that, so I guess we can do the is equal to the sum of num list res is equal to max res hands. I think that should work, right? Then we were to return res. We're missing parenthesis in line 7. Or what is going on here? Invalid literal, dude. Like, what? Invalid literal for int with base 10. Oh my gosh, that's why. I was referring to this array and not the num value. Nope. Okay, sorted. List reverse is equal to true. You assume this is reversing the first two values in numList, I think. Oh, it's my email. Oops. There we go. Passed. Yeah. Nice. Okay. Let's take a look at our powerful study program. Take a look at, let's do a binary search tree problem. Let's do a binary tree pre-order traversal. 1, 2, 3. A pre-order traversal. What is that? 1, 2, 4, 2. Okay, 1, 2, 4, 5, 6, 7, 3, 8, 9. I think that's a normal DFS. That's what we were looking at yesterday. The difference between pre-order and post-order traversal. I don't know with DFS. I don't know. I'm actually not sure. It's a pre-order, in-order, and post-order. In-order is visit the left subtree first, then the root node, then the right subtree. Right subtree, then the root node. Sort of order. Okay. Oh my gosh, dude. I'm so stupid.
Okay. We'll do this problem. We'll call it a day. I gotta start getting ready for work and things like that. So a little bit of a quicker video today, but we've been having some longer videos the past couple days. I mean, the past couple ones have been nearly 2 hours, so every single one. But we'll do the recursive approach, and then we'll do the iterative approach. So let's take a look here. The FDFS, we'll pass in the root, right? And we'll take our pass the root, and then we'll do, okay, well, what will be our base case in this case? Well, yes, if not none, if it's empty, then we just want to continue, right? Otherwise, we want to visit, we just want to visit our root first, right? So I guess this would just be our base case, right? And then we just want our recursive case, and that's, well, we want to traverse left first, right? Pre-order. Is that? Pre-order, we want to visit the root node, traverse left, traverse right. So would it just be like, we just call DFS and we call, well, node.left, DFS node.right. We're passing our node here. DFS root. Tunnel. I don't think this is even returning anything. Continue not properly in loop. Okay, DFS not that left, not that right. Turn DFS root. Let's take a look at our old one. We did for the post order traversal. Yeah, so we're doing the same thing. I feel like. Oh my gosh, dude. Jeez. Res.append, no.val. Guess we just want to put our res here, right? Continue not properly in loop. I don't understand. Why doesn't it like this? Oh, I guess we're just returning nothing. Root. Maybe. Do we want to append the node first? Why are we not outputting anything? Why are we appending?
why are we returning, wait, why are we returning empty array? Oh my gosh. Oh no. Nice. Okay. Nice. Now we're going to do the iterative method. So, do here is we take out our stack. We do while stack. We will pop from the stack. So let's do our node is equal to stack.pop. All right. I'm going to pass in our root here. Well, we obviously want to append. Right, so I guess we want to make a res array. And we can append, well, res.append node. And we can check, well, if node.left. Well, I guess if node.left, then we want to stack.append node.left. If node.right, stack.append node.right. I guess we just want to return our res. Let's see what that gives us. Ooh. Node.val. If not, node. I guess we just want to continue, right? Think about empty value. Okay, what are we getting here? I think we have to flip it around. I think we have to go right then left because of the way the stack works, because technically we're reversing it, right? Oh, whoops. We go right, we go left. Yeah. There we go. I'm going to kind of explain a little bit the reason why we have to do that. This is from yesterday. Let's create a new one, right? So it's like, you know, let's say we had node.left here and we had node.right here, right? So we have our stack here, right? So we're looping through each node. So let's do, I don't know, we'll do, man, can we get an easier test case, bro? Or something way more simple, like, I'm going to try to explain this. I mean, we don't have a lot of time, but I'm going to try and explain this pretty simply. So while we're looping here, we have our stack, right? We have our, actually, let's just do this one. Screw it. Okay, we have 1, 2, 3, 4, 5, 6, 7. Sorry. Guess do we have a photo of it? Okay, here we go, we do. Okay. Right. So with this, we have our stack, right? Okay, man, how can I visualize this? Can I move this over here a little bit? Okay, that works. Okay, right. So we have our graph here, right? We have our root, so we have our stack here. We have our stack is initialized with the root value, right? So we add 1, okay? So we come in here, we pop from the stack, right? If not node, well, like there is something there. So if this was null, then it would just continue and go to the next iteration. But here we append, let's do our res up here. We append 1, right? So then we check, well, if node.write, then we append. So if node.write, we append 3. If node.left, we append 2, right? And the reason why we're doing it this way and not the other way is because if we had node.left first, then we'd be moving this here, right? And we'd be having this here, right? But because in a pre-order traversal that we're traversing from, in pre-order we're going left, right? So we want to traverse the left one here first. And that's why we have 2 at the top of the stack, because we're always comparing, we're always processing the value at the top of the stack. Every time at the top of the stack now, we're going to add 4 and 5, right? And we're always going to add right first. So technically, our next value that we traverse would be 5, right? Then we add right first, it would be 7. Wait. Sorry, so we go 2 here, right? We traverse 4 and 5, but 5 would be the one to add, and then 4. Okay, sorry. Yeah, my bad. Scratch what I said, right? So we're at 2 now. We're traversing, we want to traverse left to right, right? So we always want the left value to be the top, and that's why we add right, because technically we're flipping it the other way around. Right, so we add 2 here to the top of the stack, right? So then we process this value, we pop here, right? And then we add, well, we would add the right, then left. So we add 5 and then 4, right? So here we always want to, we're always traversing our left value here, right? So now we're at 4, right? We pop 4 from the stack. We see that they're both none, so it skips this iteration, so we don't append anything. So then we go to 5, right? So we're at 5 here. We append 5. We pop 5. Then we check, well, we got 6 and 7, right? So then we add right here. Well, we got 7 on the right. Right, which being the next value, and then we got 6 after this, right? 6. So again, we're going to see that they don't have any children, so it's just going to skip the iteration. When we pop and check its children, we pop, and then we're back all the way to 3, right, which is our next value. So you can see here that we traverse from left, right, all the way to the right. But if this was the other way around, then we'd be traversing the right variables first, right, and then left. And that's kind of how the stack, that's why we had to flip it the other way around. I know that was a little quick, but if that hopefully makes sense. And obviously this was the opposite the other day, right? Because the other day we did the post-order traversal where we wanted to go, well, we wanted to traverse the left, the right, and then the root. So I guess what we did in that case, as I assumed yesterday, for the iterative approach, is that we started left, right? Yeah. We started with the left node. Wait, pre-order, post-order, yeah. We did left, right, and then we came back to the root. I guess we can see here where we did left, right, and then we appended the root here. The root was the last one to append, but I think if we... Is this the pre-order traversal? Let's check out our post-order one. Let's reset our layout. Let's run this again one more time. Sure that works. We'll submit it. Nice. Okay. So we submitted that, right? So we got our pre-order traversal here. Let's check out our post-order. So you can see here, post-order traversal here, right? So as you can see here, we kind of are doing the same thing, but we're going from right to left here, right? So we did it the opposite way around, right to left. But we're still appending the node right here. And we're popping, kind of doing the same thing and adding our result. So the post order is a little bit more confusing in a way than the pre-order. The pre-order is a lot more simple. Then I think there's another one. There's a in order traversal where we go left, root, right.
Curious to see if they have that in here. Do they? Well, we can search in order. Yeah, binary tree in order traversal. So they have an in order one that's next. So I guess we'll tackle that one tomorrow. But yeah, I appreciate you guys watching. Thank you.